Welcome to sig-scheduling Deep Dive. My name is Aldo Culquicondor. I work at Google, and in this session is also joining me Mike Dame from Red Hat. So we're going to talk a little bit what we do at sig-scheduling, and we are going to present you what we've been working on for the past few releases. And this includes the Kube-Scheduler and a newer project, which is the Descheduler. So sig-scheduling is the SIG responsible for the components that make pod placement decisions. That is, when you create pods in your cluster, our components are able to detect which nodes are capable of running such pod, and among all the candidates, they can select the best candidate according to certain criteria. So our leads are Juan from IBM and Abdullah from Google. And our main projects, as you might guess, one of them is Kube-Scheduler. And we have a couple of more projects which are under active development as well, such as the Descheduler, which is a component that tries to rebalance pods or reposition pods according to different criteria. And we have a newer repository, which is the Scheduler plugins. This is an incubation project for new scheduling behaviors that we don't yet want to have in the main scheduler, but we might in the future. These are the features we want to highlight for Kube-Scheduler. We're going to jump right in. The first of them is the scheduling framework. This is mostly refactoring. For us as core developers, it facilitates extensibility and also collaboration. But for other developers, it can facilitate to create their own customer schedulers. You can think of different scaling features that are required to scale a pod, and these features are contained in plugins. The plugins would implement different extension points to act on different stages of scheduling. As you can see in this diagram, we have several extension points which are grouped in 2 cycles. Each cycle corresponds to a different routine. So this scheduling framework was developed during several releases, but it was in 1.17 when we actually started using it for our core features, and since 1.18 you could configure it more easily. We're going to talk about configuration a little bit later. But in 1.19 we also have had some recent changes. For example, we have moved the permit extension point from the binding cycle to the scheduling cycle, and this is to allow certain permit plugins to avoid some race conditions. We have also merged the reserve and unreserved extension points into a single one. This is to reduce configuration burden for cluster operators. And the last feature is the new post-filter extension point. The post-filter extension point, it only runs if the scheduler failed to find any suitable candidates, any suitable nodes for your pod. And the intention is that the post-filter plugin would act in the cluster to change it in some way so that the pod can be scheduled. For example, well, our only default post-filter plugin is preemption, which is it was an existing feature for a long time, but we have refactored it into this plugin. And what preemption does is fairly easy, fairly simple. If your pod has higher priority than existing pods, these pods might be removed, might be evicted to make space for this pod that is higher priority. But you can extend, or you can create your own plugins to implement different behaviors for the scheduler. And here comes in again the new scheduling plugins repository. As I said, this is an incubation project where we incubate plugins before they are ready for production use. And as I said, the framework is centering developers, whereas for cluster operators, this looks as simply as scheduling profiles. So this is the cluster admin facing API. And what they can do is disable default plugins, enable custom plugins, and maybe reorder them. And this could be important for filtering. But our most recent feature, well, not that recent, we introduced it in 1.18 as alpha, the multiple profiles capability. This allows a single Kube-Scheduler binary to act as different schedulers. So in a single binary, you can serve different configurations, which will have different behavior. And the pods can select which profile they want to use by using the scheduler name. That is an existing API, quite old, from 1.6 or so. And in 1.19, we have graduated this API to beta. Here in the right, you can see one such configuration. For example, in this configuration, we have two profiles. One of them is simply named default scheduler, and it has no configuration, meaning that it will run with the default plugins. And as a sample, we have put here a no scoring scheduler. So basically a scheduler that does no scoring. It will just select the first node it finds. So you can see that we have used star here to disable all the pre-score and score plugins. Topology-aware pod spreading is a new scheduling feature that we implemented as plugin and as part of the core Kube-Scheduler. Basically, when you have different failure domains, such as zones or a node, or maybe if you're running on-prem, you might have your rack or your switch. Basically, this feature allows you to spread your pods among all those domains, such that you can guarantee higher availability. The constraints you can specify could be hard, meaning that if the scheduler can't satisfy them, the pods won't be scheduled. So then a preemption could happen, or maybe if you have cluster autoscaler, you could have an autoscale or a scale up. Or it could be soft, meaning that the scheduler will try to do its best to satisfy this criteria, but if it can, it will still place the pod. But you might not have the best balance. So, and one new feature we introduced in 1.18 is that you could also set a default cluster level default, which will be applied to all the pods that belong to a service or a replica set, such that you can have some kind of automatic spreading. And in 1.19, we have graduated this to GA, and we've been working in 1.19 in getting this score really influence scheduling, so that you can actually, with your soft constraints, you can actually have very good spreading. But if you don't want such strong spreading, you can also use the max skew field to control this strength. Here on the right, you can see one pod spec, which uses this new feature. You can see that we have one constraint with a max skew of 2. This constraint is defined for zones, and it's a hard constraint. you can see do not schedule if you cannot satisfy the condition. And as several other APIs, you can define a label selector to detect which pods are affected by this constraint. And this is some work we do continuously. We are always working on getting our algorithms to run faster, to use less resources, less API calls, etc., such that we can continue to meet our latency goals. In 1.17, we focused in vanilla workloads. That is workloads that don't use any specialized scaling features such as affinity or the new pod spreading API. So in these workloads, we obtain a 2.5x latency improvement. And this improvement is actually what allowed us at Google to achieve 100 pods per second in 15K nodes, or clusters with 15,000 nodes. We also improved the latency of specialized features such as pod affinity. Here we actually obtain a very big boost. We achieved 24x improvement for preferred affinity and 7 times for required affinity. In 1.18 and 1.19, we focused on, again, these specialized features. We even improved affinity further. We achieved two times improvement in latency. And as we were preparing to graduate pod topology spreading to GA, we also worked on its latency, and we also obtained a 2x improvement. And now this spreading, this feature is, if you're familiar with the legacy selector spread priority, this new plugin is equivalent in speed. But as I said earlier, it has much stronger spreading guarantees. In 1.18 and beyond, we want to focus on preemption. We want to make it faster to either preempt faster or skip it if we already know that preemption is not helping. And we also want to focus on the effect of unscalable pods. Once your cluster has a lot of unscalable pods, it can affect the latency of the scheduler. So we want to really solve that. Next, Mike is gonna present what's new in the descheduler. Mike?
All right, thanks, Aldo. My name is Mike Dame. I work a lot with the scheduling SIG, and I'm also one of the currently active contributors to the Descheduler project. If you're not familiar with the Descheduler, it's actually a sub-project that's been around for a couple of years, but it's recently started to gain a lot more traction and a lot of interest from new contributors and people that are finding that it works for their use cases. And basically what it does is, the problem that you have with the scheduler is that it will take a new pod and put it onto the cluster based on the series of defined plugins. But once the pod is scheduled, nothing happens to counteract for that in case the state of your cluster changes. So say if a pod gets scheduled onto a node and then later on that node gets some sort of taint or a label gets applied to it that doesn't match the affinity that the pod originally had, nothing will happen with that. But the descheduler is a tool that will run periodically, either as a job or it can run in a control loop. And it'll periodically look at the state of the cluster and look at the pods and make sure that they match what they should. And if they don't, it'll evict those pods. So say if the pod is on a node, like the example that I gave, and a new label gets applied to that node that doesn't match affinity, the descheduler will see that and evict it. So we've had a lot of improvements on it recently, just trying to make it more reliable and accessible to new users. Anyone that's interested in contributing to it is welcome to, but I'm going to go over a couple of the changes that we've done so far in 1.18 and 1.19. So the first thing that we did was we have now decided on aligning the descheduler's releases with upstream's releases. So that means that we're going to be tagging release branches along with the upstream release schedule. So this means that you'll know what version of Kubernetes the descheduler is compatible with if you're running it, and it also helps us track the past 3 versions of Kubernetes that we want to support with it. So you can know that if you're running the 1.19 based version of the descheduler, that should work with 1.18, 1.17, and 1.16 as well. So that is what we're able to track a lot easier with these matching tags. And it also gives us a more regular release cycle to make sure that we're updating to the upstream dependencies, making sure that everything is compatible and that you can grab the latest descheduler and run it in the latest Kubernetes and it'll work. Another part of that is that we've published some production containers for anyone to consume. You don't need to build your own descheduler now. If you just want to use the default that's available, these are published on GCR.io, and they'll be tagged with the matching release numbers, so you can grab this and run it in your cluster without having to build the descheduler yourself, which makes it a lot easier to run. So the next thing that we did was we've added a couple new strategies. The full list of available strategies for the descheduler is on the README for the repo. I've mentioned a couple of them so far, such as node affinity, pod affinity. There's strategies that will remove if you have duplicates of pods running on a node and you want to spread those out more, it'll try to evict some of those duplicates and hopefully they get rescheduled onto a different pod, so it keeps your availability up. But the new things that we added in 1.18 and 1.19 are these 3 strategies here. One will remove pods that have too many restarts. So this can be helpful if you have pods that are constantly crash looping for some reason and you want to get in there and evict those pods, maybe to kick them onto a new node that has better availability for them. Maybe they're crash looping because they're having trouble connecting to some mounted network volume on one node, but once it gets evicted, it goes onto the new node and then it works for it. That's what this job does. And that takes 2 parameters, the threshold of how many restarts you want to consider for eviction, and also whether or not the init container restart should be factored into that. The next strategy that we added is a pod lifetime strategy, which just removes pods that are over a certain number of seconds old. So that's pretty self-explanatory. If you have long-running pods and you want to evict those in favor of newer pods, try to get new pods into the system, that is what that is for. The third one that at this time is in progress, but we're targeting is for the 1.19 release cycle, is a topology spread strategy, which matches the topology spreading plugin that Aldo mentioned and looks at if your topology becomes uneven at some point while the pods are running, it's going to go through and try to work on or try to evict those pods that will hopefully be rebalanced in the way that you want with your strategy. So important thing to note about the descheduler is that it doesn't try to reschedule any of the pods. What it's doing is strictly evicting pods that don't match what they should, and then it's up to the scheduler and those pods owning controllers to recreate those pods, and it's optimistic that the scheduler will put them back where they need to go. So having these matching strategies is very helpful for keeping a cluster balanced actively, And I'll come back to that in a minute with something else that we were talking about for future improvements with the descheduler. But with these, like it says here, we are always looking for new ideas and new strategies that can be added to the descheduler. Like the scheduler, there's infinite number of ways that you can imagine that you might want to come up with a strategy for how your cluster should be balanced or how that could be violated and what you want to do to address that. So any new ideas with use cases for them are welcome in the repo, and any new contributors also very helpful. So after those changes, we have a couple miscellaneous improvements to the repo. One of those is that we just finalized, we're going to be publishing a Helm chart automatically with our release, so this will be easier for people who are consuming Helm charts to publish or to run the descheduler. They will be able to grab those from our GitHub repo and be published with GitHub pages, make it a little easier to deploy. Another thing that we're adding is the ability to run the descheduler selectively on pods based on their labels or on specific namespaces. This is something that we've had people ask for. I just want to run the descheduler to keep this one project balanced instead of having it affect my whole cluster. That's what these will provide for you. And another thing that we're looking at in the future is being able to control what priority, based on a priority class threshold, what pods are eligible for eviction too. So if you want to exclude a certain number of pods based on your custom defined priority class, you'll be able to do that in the future. This is something that we're working on in progress. Currently, it only excludes pods that are system critical based on priority class. There are various number of ways that you can also exclude pods, but these are just some of the other ways that we're making it configurable. We also updated the descheduler to be based on Go 114. That's with keeping in line with upstream in 119. We added some issue templates to GitHub so that new users can more effectively propose issues, raise up bugs, and we can communicate better with how to resolve those. And then we just had some various quality of life improvements to the code, some refactors. One of those being that we've improved the logging, we've improved the ability to see why pods were evicted in the logs, as well as raising events when pods are evicted that specifically say it was evicted because it violated the pod anti-affinity of the node, or whatever reason happens to be. And various other code refactors that are too small to mention here, but definitely improve the readability and the ability for people to contribute to the code. Looking ahead, we've got some plans that we plan to contribute or continue improving the code base. One of those is we're looking at our API to configure the deschedulers strategies. We want to make that a little easier to configure and make it a little more extendable for users to add in new strategies. Another big thing that we get asked a lot, that we've seen a lot of people requesting, is the ability for it to be based directly on the scheduler's plugins and use that code to be able to make its descheduling decisions. And that's something that we're definitely looking at and appreciate any help that people will be willing to join on. One of the big blockers for that right now is the ability to easily import the scheduler plugin code. It's pretty tied into the rest of the upstream core Kubernetes code base. So part of the task that we're taking on is trying to go through where the plugins are tied in and where we can break those dependencies so that you can more easily import just the packages that you need to get certain plugins or all of the plugins without pulling in the rest of K/IO/Kubernetes. And that's something that we're working on, and there's issues in sig-scheduling upstream that you can find and help out with that if you'd like. But those are all of the main improvements that I had for the descheduler. Yeah, I don't know, that's all I had. Aldo, did you have anything else?
That's all from my side as well. Thank you for joining this session.
Yep.
Okay. So we're now live in the Q&A. We have a few questions here. Let me take the first one. Wasn't there a plan to implement affinity policies that are enforced during execution? For example, required during scaling, required during execution. Is the descheduler a substitute for that? So let me answer first from the Kube-Scheduler perspective. In general, yeah, this option has been discussed in the past, and there's an immediate pressure for it, so we are not doing it in the next release, or unless there are contributors that come in. But this there is a problem here, because such feature would require that the Kube-Scheduler starts watching running pods, which it doesn't today. But the API is not just about the scheduler. It can be enforced by other components. For example, we have eviction that is done from the kubelet as well, for tolerations, for example. So it is possible that we could implement this feature through the descheduler once it becomes more of a main project in Kubernetes. I don't know if Mike, you want to add something to this topic?
Pretty much exactly what you said. It's come up a couple times before, and I think in the past when I have seen it come up, people tend to point to the descheduler for it. I think that if you run the descheduler, you'll basically get that behavior right now if you're looking for the required during scheduling, required during execution, but it's not, like I said in the presentation, the descheduler isn't watching pods all the time. It's running on whatever interval you're setting. So sort of like how the scheduler would need to start watching pods all the time to get this perfectly, the descheduler will probably get you close enough if you're looking for that behavior.
Let's go to the next one. What do you think about potentially integrating descheduling into the scheduler? I don't know if this has been discussed before, but basically I get this as putting it as a separate routine instead of a separate binary. Mike?
Yeah, I've heard people ask about it before. I think it goes back again to just like what we were just saying about, if the scheduler was going to be watching pods, it's kind of taking the opposite behavior of the scheduler. So it would have to run as like a separate routine, or maybe be a separate binary, but it depends on how you want to define integrating it into the scheduler. I don't think right now there's too much looking at it, and we're trying to get some of the scheduler actually integrated into the descheduler by getting those plugins and making them available to be imported and use the descheduling strategy. So in that way, the descheduler is kind of a weird implementation of a scheduler in a way on its own. So I don't know if we're really going to be looking at moving descheduling into the scheduler anytime soon. But if there is enough interest for that coming up, I would not be against it. I don't have any reason to be against it. But I just don't think many people have pushed too hard for it yet.
But on the other hand, it's also good to have some separation, so for more opportunities of failover. This kind of goes with the next question. What was the reason behind starting a different project for descheduling instead of starting off by studying the scheduler? Well, there is, first of all, the ability to iterate faster. If you have a separate project, you can incubate. You can put it in a separate a separate repository and people can contribute faster, because the scheduler is old. You don't want to break it. You don't want to break people's clusters as they update. So it's safer to start a separate project, and even better for this kind of thing where you have a entirely separate routine that needs to start. So it was safer in that sense. Anything to add?
Yeah,
Mike?
and tagging on to that, like you said, the people can contribute a lot faster to the descheduler as a separate project. We're not so strictly tied to Kubernetes release cycles, even though we try to keep them lined up. Code freezes and stuff we can be a little looser on, and just we have a faster iteration that people can contribute to.
Yeah, as the project progresses, it could actually be more in line with stable releases. But it could always stay as a separate project, just like the cluster autoscaler, for example. This is another question. Thanks for updates. What do you think is the most exciting, challenging problems for Kubernetes scheduling today? I'm gonna say basically two things. One is scalability. There is a lot of people in the community asking for some contention. I mentioned in the talk this problem of unscheduled pods that affect scheduling. So that's one. And it's hard because there are so many events happening in the cluster. Pods removed, or pods terminated, or nodes, new nodes, or removed nodes. So it's not easy to come up with a strategy to retry pods that are pending. And another interesting problem is batch scheduling. Basically, scheduling multiple pods at the same time because they have a tight relationship. So one cannot start without the other. That is hard because the scheduler today looks at a single pod at a time. So that's a problem some contributors are looking at, and they are already experimenting with plugins in the scheduling plugins repository, and they are iterating there as well.
Yeah, batch scheduling
Anything
is
else?
definitely one of the bigger ones that we've been trying to crack for a while. And the scheduler plugin framework has let more people try to take on that challenge. I know topology-aware scheduling is also another thing that we have the default topology spreading plugin that you talked about in the presentation, but I know that there's a lot of people trying to work on their own solutions for that too. I think that there's an entirely separate topology-aware scheduling channel in the Kate Slack where people are working on really interesting solutions to it. And I'd pop in there every now and then to see what's going on, but gets a little over my head.
Yeah. Let's go to the next one. Is there a memory type aware scaling available? Example, Kubernetes nodes with DRAM versus nodes with PME, MRAM, SRAM, etc. Not that I'm aware of. There is some discussion about node topology. So if you have NUMA nodes, there is that discussion that is already started. And I imagine this problem would be kind of similar, but I haven't seen any discussions around this.
Yeah, I would say the same thing. It's pretty much NUMA-aware scheduling has been probably the closest that people have talked to about that, but not very much beyond that.
And I'll leave the next question to you, Mike.
Yeah, the next one saying there's the weird problem of trying to pull in scheduler code to have better default strategies in the descheduler. Was this a consideration that was made during the start? I wasn't actually around for the very start of the descheduler, but it's been something that was being considered for a while, and especially now that the framework has become the main way that the scheduler configures its plugins. So really, once we got the switch to the scheduler framework with plugins, the consideration of bringing those plugins into the descheduler started to come up right away. So we have been thinking about that for a while, but it wasn't a main driving force of developing the framework, as far as I'm aware, although, but it's something that we want to make easily importable now. So that's just a nice side effect. And now we are kind of using that to drive breaking out these plugins. We have the scheduler plugins separate repo that I think we're going to try to move some plugins to eventually, or at least it's an incubating repo for new plugins now. Something that we've considered and thought about.
And as we mentioned in the talk, there is also a huge drive to clean up the dependencies. Basically, try to bring the core part of the algorithms into separate repository that is easier to import from other projects, so that this is less of a problem. There are no more questions.
Nope, it looks like that's it.
How much time do we have left?
Yeah, it was looks like we're actually just about a little over our time, actually.
Okay.
So
So we are
there
also in
are,
the Slack.
yep.
If you have any extra questions, you can post them there, and we are gonna answer.
Yep, we're in the 2 QCon maintainer track Slack channel for CNCF, and then also obviously sig scheduling regular Kate Slack. So thank you. This was great. I hope it was informative. And yeah, thanks for coming.